Analysis of beam. An example of analyzing a beam is elected to illustrate some features of ELPLA for analyzing beams. All beam members have a cross-section dimensions of 0.2 meter by 0.5 meter height. Geometry of the beam and loads are shown. The angle modulus of the beam member is 2 pi 10 power 7 kilonewton per meter square. To analyze the beam is divided in beam elements. Each has a length of 1 meter. This tutorial manual will not present the theoretical background of modeling the problem. For more information concerning the method of analysis, a complete reference for numerical calculation method is well documented in the user's guide of ELPLA. After opening ELPLA program, we will start from file list and select a new project. Then we will select analysis of plane frame from the calculation method wizard. Analysis of plane frame, then next. From system of symmetry, we will select unsymmetrical system, then next. And from option, we will select supports, then save the project to the destination folder. Maybe we can save it as beam, then save it. Next, from project identification, we can write here the project title and project name and modify date. Project title may be analysis of beam. And project name beam, then save it. After that, we will select FENet data and we will select the rectangular type here with total length of 11 meter, and we can select the height as only 1 meter to draw the FNet. Then next, and the generation type will be the first type here, square type, and from the grid definition we will select grid intervals as only 1 meter in X direction, then finished it. Here we have the grid. We can select from setting, plot parameters, and FENet. We can unselect display node numbering for FNet. Save it and close. Then save and close. Then we will select girders here. First we will select girders group, and from cross section definition we will select rectangular cross section. The Young's modulus will be 2 pi 10 power 7, and the height will be 0.5 meter and the width is 0.2 meter. We don't have girder weight here for this problem. Then okay, and then we will draw the beam member as separated beams when we have change in supports and the distributed load. So we will add the first beam as 2 meter, then we have intermittent hinge here, and after that we have a beam with 3 meter length with uniform load, and then we can add the next beam as 3 meter. We don't need to separate the beam when we have concentrated load or concentrated moment, then we will draw the last element here as 3 meters. Then we will save it and close it. After that, we will draw the loads or select loads here. We can select setting, parameter, and from FENet we can unselect color girders and draw girder thickness here. Save it. Also we can unselect display coordinates here or display element numbering. Okay, save it and close. Here we have the beam only. Okay, back to loads, and first we will draw the uniform load. We will select edit members load. For this element we have uniform load of 80 kN per meter. We will double click on it. Here we have the load, and we can select self weight, snow load, wind load. Here is the self weight. It will be 80 kN per meter, and OK. And we also have another uniform load here is 40 kN. OK. The last thing, we will select the node to add concentrated load or concentrated moment here, and then we will select add nodal loads, and for the bending moment here or the vertical load will be 100 kN and the moment will be minus 60 kN meter. Okay, then we will save loads and close it. After that we will select supports. We have intermediate hinge here, so we will edit hinge and double click for the left element and select the right node or the end node to be hinged, J. Okay, and for this element we will select the right element or right node to be hinged, I. Then OK, and then we will select nodes. For supports, the first node here is fixed support, so we will add supports from here, and we will write here 0 for displacement in X and Y, and also there is no rotation here to be 0. Okay, and for the last node here will be ruler support, so also we add supports and select only W will be 0. Then OK, and save it and close. Then we will go to solver and select computation of all. After that we can draw results. Maybe we can draw results in plane. We can draw system of loading here, or boundary condition or girder system if we have different elements of girders. We can draw net numbering, coordinates. We will select system of loading and OK. Here we have system of loading. We can add supports to this drawing from view grouping and supports, or select supports here. Here we have supports and loads. After that we can draw also results, supports reaction. We have supports vertical reaction and moment. For example, moment here also and also we have results of uh, normal force, bending moment, shear force, displacement, U and V, rotation. For example, bending moment here, and also we can draw shear force and frame deformation. For example, we can undraw ligand here to have more space. From setting, select ligand and unselect display ligand and save it. Thanks.